Imagine opening Netflix after a long day, your brain fried, your time limited, and within seconds, the perfect show pops up on your screen, almost like the app has crawled into your mind and whispered, "You're going to love this." You scroll a little, and somehow every row feels oddly tailored to you. That crime drama you didn't know existed, the quirky animated series that matches your weird sense of humor, the foreign film in exactly the language you've been trying to learn. Now here's the wild part. Behind that feeling of "Netflix just gets me" is not one single magical algorithm, but an entire army of algorithms working together, competing, cooperating, being constantly tested in real time on millions of people to win one crucial battle, keeping you watching instead of giving up and going somewhere else. And Netflix believes this invisible recommender system is so powerful that they estimate it saves them over $1 billion a year in reduced cancellations and increased engagement. Today, we're going to crack open the black box and walk through the real science behind the Netflix recommender system, how it works, why it matters, and how it quietly shapes what the world watches. Before we dive into the guts of this thing, if you're into AI, data science, or just love understanding how the apps you use every day actually work, make sure to hit that like button, subscribe, and turn on notifications so you don't miss the breakdowns of the papers that are literally running the modern world. Now, let's get into the story behind Netflix's brain. This video is based on a paper called The Netflix Recommender System: Algorithms, Business Value, and Innovation by Carlos A. Gomez Uribe and Neil Hunt, two of the people who helped shape how Netflix recommends what you watch. The story starts with a simple but brutal problem: choice. Traditional TV was easy in one sense. You turned it on and watched whatever was playing. But internet TV is different. Suddenly, you have thousands of options, on demand, on every device, at any time. That sounds like paradise, but psychology tells us it's also a trap. When you're tired and you have a huge menu of options, your brain short-circuits. You get overwhelmed. The paper points out that Netflix has learned a harsh truth from user research. The typical member loses patience after about 60 to 90 seconds of browsing, after maybe 10 to 20 titles, and if they haven't found something compelling by then, the chance they just give up climbs fast. That's the moment of truth Netflix is obsessed with. In that minute, their recommender system either wins by serving you something you'll click, or it loses you to TikTok, YouTube, gaming, or just bed. And remember, Netflix isn't just showing a small, curated lineup. They carry a huge catalog: blockbusters, obscure documentaries, kids shows, stand-up, foreign dramas, micro-niche anime that only a tiny sliver of people love. Internet TV makes it possible to serve all of that, but only if the recommender can match niche content to the exact people who care. So how do they do it? The first big idea in the paper is that there is no single Netflix algorithm. It's actually a whole ecosystem of algorithms, each with its own job, all coming together on one crucial screen, the Netflix homepage. Picture that homepage as a giant grid. Every little box is a video. Every horizontal row has a theme and is powered by a slightly different algorithm. Some rows are trending now. Some are because you watched X. Some are genres like suspenseful movies or romantic comedies. Others are hyper-personalized rows like top picks for you. And Netflix doesn't just decide what shows go in the row. There are algorithms deciding which rows to show in the first place, how to order them, and even which image, summary, or label to display to persuade you to click. Let's start with the workhorse, the Personalized Video Ranker, or PVR. Imagine lining up the entire Netflix catalog and asking, for this specific person, what is the best order to show all of these titles? That's PVR's job. For a given user profile, it ranks every video in a personalized order. Then, when Netflix wants to build a suspenseful movies row or a comedies row, PVR takes that genre subset and sorts it according to what it thinks you personally are most likely to watch. This is where personalization meets popularity. PVR doesn't purely follow your unique taste. If it did, it might make weird, overfitted bets based on a tiny bit of your history. Instead, it blends in popularity signals: what's big overall, what's trending over different time windows, what's grabbing attention across the service, so that your recommendations ride the edge between just for you, and socially validated. That popular row you see that looks a bit generic? It's still influenced by personalization, but it leans heavily into what's broadly working across millions of members. On top of that, there's a specialized algorithm called the Top N video ranker, which is like PVR's cousin with a different obsession. While PVR is responsible for ranking the entire catalog or big slices of it, Top N only cares about the first few ultra-premium slots, the absolute best handful of personalized picks for you right now. That's what powers the Top Picks for You row. You can think of it as a sniper instead of a shotgun. It tunes and evaluates itself based on how well it performs just at the top of the list, not across everything. Then there's Trending Now, which is Netflix's way of capturing short-term vibes. This isn't just what's popular overall in a vague sense. The trending ranker looks at what's suddenly spiking in the last minutes, hours, or days. It picks up recurring seasonal patterns, like the yearly surge in romance around Valentine's Day or horror near Halloween, but also reacts to sudden real-world events, like a big storm driving people to watch disaster movies and documentaries. And of course, even trending is flavored with personalization, so you and your friend might both be seeing what's hot right now, but through very different lenses. Another key player is the continue watching algorithm. This may sound simple, just show me what I started but didn't finish, but when you look closely, it's actually a subtle prediction problem. Did you pause that show halfway because you were tired, or because you secretly thought, meh, this isn't for me? Should Netflix push you to resume it at the top of your homepage, or quietly let it slide away? The continue watching ranker looks at signals like how far you got into the video, how long it's been since you watched it, what you've watched instead since then, and even the devices you're using. Stopping near the very beginning might indicate, nope, while stopping after binging several episodes might just mean, I'll get back to this. That quiet little row is trying to infer your intentions from your behavior without ever asking you directly. Then there's one of the most iconic parts of the Netflix experience, the because you watched rows. These are powered by what the authors simply call SIMs, as in video-to-video similarity. For every title in the catalog, Netflix maintains a ranked list of other titles that are considered similar. That similarity might come from what people co-watch, from metadata like genre, cast, or themes, or from more complex machine learning models that infer deeper structure. What's interesting here is that the Sims list itself is not personalized. The similarity from show A to show B is computed the same way regardless of who you are. But the decision of which because you watched rows to show on your homepage is personalized. So the system might say, you watched House of Cards, here are 50 similar titles, but then it picks which of those to show you and in what order based on your own taste and history. There's a great example in the paper where human intuition fails. Netflix ran tests comparing two different sets of similar to House of Cards recommendations. One set looked, to humans, more obviously related. Political dramas, similar tone, same country. The other set leaned more into popularity and had titles that didn't feel as tightly related. If you showed both to a panel of humans and asked, which is better? Most people would choose the more obviously similar list. But when Netflix ran A/B tests, the less intuitive, more popularity-weighted list actually performed better. People watched more. This is a recurring theme. Your gut about what recommendations look good is often wrong. So far, we've talked about how individual rows get their content, but there's another layer of intelligence, how the entire page is constructed. Netflix members don't just differ in taste, they also arrive in different moods. Sometimes you want comfort food TV, sometimes something serious, sometimes something for the kids. On top of that, multiple people often share one account or even one profile. So Netflix doesn't just rank videos, it ranks rows. For each member, there are tens of thousands of possible rows it could show, different genres, different BYW rows, different mixes of personalized and popular content. In the early days, Netflix used a template. Row 1 is type A, row 2 is type B, row 3 is type C, and so on. Everyone's homepage had the same structure, only the content inside the rows changed. But as the system evolved, that wasn't enough. Now the page construction algorithm picks and orders rows dynamically for each member, optimizing for both relevance and diversity. For one person, the page might be packed with "because you watched" rows. For another, there might be 0 BYW rows and mostly genres and top picks. The goal is to build a page that helps you quickly skip what's not for your current mood and zero in on something that is. And then there's evidence selection, the part that decides what you see about each title. Which artwork, which synopsis, whether to highlight "because you watched X" or "winner of 3 Oscars" or "starring that actor you love." Even the thumbnail image you see for the same show can differ between users. Netflix tests different images and evidence to see which versions are most effective at convincing the right people to click. The recommender doesn't just decide what to show, it also decides how to pitch it to you. Now let's talk about search, because even that turns into a recommendation problem. About 20% of Netflix viewing comes from search rather than from browsing the homepage. You might start typing "Breaking B" or "Keanu" or "French", and Netflix has to guess what you mean with just a few characters, on a TV remote no less. Sometimes you're searching for something that's not even in the catalog, like "The Usual Suspects", when Netflix doesn't have it. Instead of giving you a dead end, the system turns that into a recommendation moment. It uses search algorithms to figure out what titles are related to your query by theme, by genre, by co-watching patterns. When you search for something Netflix doesn't have, it's effectively saying, "We don't have that, but if you were in the mood for that kind of thing, here are the best alternatives." There are algorithms to match queries to titles, algorithms to detect broader concepts or genres hidden in your query, Fren becoming French movies, and then recommendation algorithms to rank the best videos for that concept.
All of this is powered by a mix of machine learning techniques, things like supervised models, clustering, topic modeling, and especially variants of matrix factorization that learn dense embeddings for users and items from massive viewing data. But the technical details are only half the story. The other half is, how do they know if a new algorithm is actually better? This is where the paper gets into A/B testing at Netflix scale. Here's the key. Netflix doesn't optimize for clicks, or even just for stars or ratings. Their business model is subscription-based. You pay monthly, you can cancel anytime, and Netflix only makes money if you stay. So the ultimate North Star is retention. Do people stay subscribed longer? The problem is that changes in churn are small and noisy. Dropping churn even by 0.1% is hard and requires a huge number of users to detect statistically. So Netflix uses engagement, things like hours watched over months, as a powerful proxy. Engagement correlates with retention. If you're watching a lot, you're more likely to feel Netflix is worth paying for. So for each algorithm change, Netflix runs randomized controlled experiments. Users are split into cells. One cell sees the current production algorithm, the others see different variants, maybe a new PVR model, or a new SIM strategy, or a redesigned homepage layout. These experiments run for months, often with millions of users, and Netflix tracks. Are people finding more videos through the changed feature? Are they watching more overall? Are they canceling less? But here's where it gets tricky. A change might make people click more on that specific row, but not increase total viewing, because it just cannibalizes viewing from somewhere else on the page. Or you might see a small bump in engagement that isn't strong enough to produce a detectable difference in churn. So Netflix builds a hierarchy of metrics. Local metrics. Are people using the changed component more? Overall engagement. Are they watching more overall? And retention. The gold standard is local metrics up, engagement up, retention up. When that happens, the change is a clear win. But sometimes they see weird results, a statistically significant win in retention with no change in engagement. That's a red flag. In those cases, they often assume it's just random noise and rerun the test. True wins tend to repeat, fake ones don't. They also use statistical techniques like variance reduction and stratified sampling to make tests more sensitive. And another subtle point, they prefer to test on new users when possible. If you radically change the product for existing users,
You might be measuring how people react to change itself, not how good the new experience is in the long run. New users haven't seen the old design, so their behavior reflects their genuine reaction to the new experience. One fascinating metric the paper introduces is effective catalog size. Think of it as a way to measure how widely viewing is spread across the catalog. If everyone is watching the same one or two shows, your effective catalog size is tiny. If viewing is spread evenly across tons of titles, your effective catalog size is huge. Netflix shows that personalization dramatically increases this effective catalog size compared to a generic, non-personalized experience. In simple terms, without recommendations, most viewing would cluster into a handful of mega hits. With personalization, Netflix can push people into the long tail, matching smaller shows with their perfect niche audience. That's not just good for viewers, it's essential for Netflix's strategy, especially as they invest in original content and acquire niche titles that wouldn't survive in a broadcast model. The payoff of all this? According to the authors, Netflix's recommender system and personalization efforts reduce cancellations by several percentage points. That might sound small, but at Netflix scale, it translates into more than $1 billion per year in value. And that's just the measurable, direct impact within existing subscribers. They also suspect that a better personalized experience boosts word of mouth. People who love their recommendations talk more about Netflix to their friends, accelerating growth. On top of these wins, the paper lays out a whole frontier of future challenges. One is going fully global and language-aware. Different countries have different catalogs because of licensing. You can't just run one big algorithm trained on a single global set of movies and shows. You have to understand which titles are available where, and which languages each user can understand. Netflix is working toward a single global recommender system that shares data intelligently across countries while respecting catalog differences and language constraints. For instance, if a Thai-speaking user would love House of Cards, but there are no Thai audio or subtitles, maybe you shouldn't recommend it. Or you should at least prioritize titles fully localized for them. Another challenge is presentation bias and feedback loops. Popular shows get recommended more, which makes them even more popular, which makes them seem better to the algorithms. Meanwhile, hidden gems might never get the initial exposure they need to prove themselves. The paper hints at the need to explicitly account for what was shown to users, not just what they watched, and to inject controlled randomness to explore new content and break out of echo chambers. There's also the page construction problem itself. Netflix spent years moving from a rigid template-based layout to a fully personalized homepage, and they see enormous room for improvement. You can imagine future systems that dynamically change layout, density, and emphasis based on your device, your history, even your mood. Then there are classic recommender problems, cold start and shared accounts. New users haven't watched anything yet, so Netflix uses a sign-up survey to bootstrap their taste, asking them to pick from a curated set of titles so the algorithms have something to work with immediately. Even then, new users are the most likely to cancel, so getting those early recommendations right is critical. Shared accounts add chaos. Kids and adults might use the same profile, leading the system to confuse Paw Patrol with prestige drama and mess up both sets of recommendations. Netflix allows multiple profiles, but many households still share. The system has to learn to cope with mixed signals, detect kids' viewing patterns, and adjust over time as tastes evolve, especially for children, whose preferences change rapidly as they grow. Finally, we come back to evidence selection, the art of choosing the best way to present each recommendation. Imagine Netflix has 4 different poster images for the same show, one highlighting a romantic couple, one highlighting an action scene, one focusing on a famous actor, and one that feels darker and more serious. Which one should you see? The answer might depend on what you've liked in the past. Maybe you click more when you see a recognizable star, or maybe you avoid romance but love gritty crime drama. Evidence selection is where machine learning connects with design and psychology, tailoring the pitch of each title so it resonates with each viewer. When you put all of this together, the story of the Netflix recommender system isn't just a story about one company's tech stack. It's a glimpse into the future of how choices will be mediated across many parts of our lives. What we watch, what we read, where we travel, how we learn, even how we make health or career decisions. We're moving into a world where the most valuable real estate isn't a storefront or a billboard. It's the first screen you see when you open an app. The battle for that screen is fought with algorithms like the ones we've just explored. And in Netflix's case, they're using A/B tests, machine learning, and a staggering amount of data to squeeze every bit of value out of those first few seconds when you're just sitting there, staring at a grid of thumbnails, wondering what to watch. If you enjoyed this deep dive into the Netflix recommender system, and you want more breakdowns of the research papers secretly running your favorite apps and shaping the tech world, do me a huge favor. Hit like, subscribe to the channel, and drop a comment telling me which system you want to see next. YouTube, TikTok, Spotify, Amazon, you name it. Thanks for watching, and I'll see you in the next one.